frequently called the most cosmopolitan city of the Midwest, Detroit today stands at the threshold of a bright new future, one rich with the promise of fulfillment. In this bustling city on the Straits, where British and American flags soon followed the French, a spirit of brotherhood was born and nurtured, foreshadowing the city's national character. Here, people from many nations have met and mixed and built a metropolis of thriving commerce and culture. The Detroit River flows past the city's front door, the world's busiest waterway. This river is a vital passage to the Great Lakes and to the St. Lawrence Seaway beyond. Detroiters just naturally take to the water. They enjoy more sparkling, pure water than any similar area in the world. Detroit, the crossroads.
It's fun to eat supper with your family, especially when there is good food on the table. Strong, healthy bodies. They are good foods to eat. Father is certainly enjoying his supper. So is Carol. So is Mother. Just look at that plate. Aren't you feeling well, Bill? Aren't you hungry? What can be the matter? After supper, it's fun to play a while before bed. But there's still something wrong, isn't there, Bill? In a moment, you'll know what it is. Yes, Bill, you're getting a stomachache. When you have a stomachache, it isn't any fun to play. There it is again. Poor Bill. What now? We'll soon know, because here comes Mother. Mother can tell right away that Bill isn't feeling well. So, what happens next? Yes, Bill's put to bed to get some rest. Now, why does Bill have a stomachache? He didn't eat anything bad today, did he? Well, perhaps it wasn't what he ate, but the way he ate it. Why, even this morning, Mother was a little worried. Let's go back to this morning and see how Bill's stomachache might have happened. Bill wasn't at breakfast on time this morning. You see, he didn't get up when Father first called him. Oh, Bill got to the table, and he ate his breakfast, or rather, part of it. Orange juice, one big gulp of it. Milk for the cereal, splash it on. No time to waste. Gobble down the cereal, a couple of big spoonfuls, one right after the other. But leave most of it. Now for the eggs. More good, healthful food. But what about Bill's eating habits? Into his mouth went some eggs.
Steel industry means to this great business of highway construction. Actually, construction of a highway bridge starts almost as soon as the site is selected. It has to, because there's a tremendous amount of design and engineering work to be done. The topography largely determines the type of bridge to be used. Every piece of steel in it is cut to strict specifications at the steel company's fabricating works and assembled into sections of convenient size for transportation. These sub-assemblies are scheduled to arrive at the bridge site in the order in which they are needed. Here, as elsewhere, steel serves not only to support the roadway, but to hold together and reinforce the concrete pavement. Everybody knows about famous steel structures like the Golden Gate Bridge, the George Washington Bridge, and the Chesapeake Bridge, but few people think of them as what they really are, highways over water. Not just connecting links between two highways, but part and parcel of the highway itself. From the standpoint of actual mileage, of course, most of a highway is built on the ground. And even in the first steps of construction, steel enters the road building picture. Road building today is no pick and shovel operation. For yesterday, the roads more or less followed the contour of the land. Today, the shape of the land must be made to conform plan for the highway. Ridges must be cut away and gullies filled in. Steadily over the years, the jobs have become bigger and tougher. And to meet the challenge, heavier and more specialized
responsibility to its policyholders and beneficiaries. Each year, the company must set aside sufficient funds called reserves, which, increased by interest earnings and future premiums, will enable it to pay all obligations under policies that will fall due in the years to come. The law recognizes the necessity of such reserves and requires that they be maintained. These reserves, plus funds in process of payment to policyholders and beneficiaries, together with miscellaneous liabilities, constitute the company's total obligations, about $8,049 million as of December 31st, 1947. To meet these obligations, Metropolitan's assets at the close of the year amounted to $8,548 million, an increase of about $503 million during 1947. It is then seen that the assets exceed all liabilities by $499 million. This is a safety fund, which is available to meet unforeseeable contingencies, such as the epidemic we had in 1918-19, or stormy economic weather, such as the Depression in the 30s. Metropolitan's asset dollars are kept busily at work in sound investments. However, these are trust funds, and the company's first consideration must be safety of principal. As a result, we do not put money into investments of a speculative nature, such as common stocks, for example. But while Metropolitan's dollars are working for policyholders, they are benefiting all of us, helping provide jobs and the goods and services we all need and want. At the close of 1947, the biggest share of the company's investments was in United States and Canadian government bonds, a total of about $3,800 million, accounted for by the heavy purchases made during the war years. Since the close of the war,
traverse the deep. On land, oil feeds the fiery furnace or drives the diesel engines along far-flung rails of steel. And on the open road, well, you know what makes your auto run. For millions of years, this source of power slept peacefully in the dark recesses of the earth until modern magic loosed the liquid energy from its subterranean prison. Great areas became forests of towering derricks. And here's how the petroleum forest grows. A cellar is dug, and a rotary table to turn the drilling stem and the bit is set in place. Round and round the rotary goes, drilling deep down to oil. A steam engine drives the drilling mechanism. They're inserting a length of pipe, lengthening out the stem for deeper drilling. A new joint is waiting. Oil field workers are called drillers, roughnecks, roustabouts, rope chokers. The oil field treats our ears to odd and colorful names. Now the drilling stem has been lengthened, then round and round once more. Down through layers of sandstone, shale, limestone, down to astonishing depths. This well 5,000 feet, some 10,000, 2 miles into the earth. And then, after weeks of drilling, fighting against natural obstacles, the drill at last reaches the oil sand, porous rock, which holds the oil much as a sponge holds water. Next, the casing is lowered to the bottom of the hole and cemented in position. Then drilled through the oil sand, and a screen is installed at the base of the casing. The screen extends down into the oil sand. The oil flows through the screen, up through the small pipe tubing to the surface. So they've struck oil, and now the well must be cleaned of the mixture of drill mud and oil. Some wells flow of their own pressure. Others must be pumped, need power. The power is transmitted to groups of wells, the ever-swaying rocker arm, the rhythm of pumping, the unceasing heartbeat of the oil fields. A 24-well hookup is the height of oil field power. Pumping black magic from 24 drillings in the earth, all at the same time, out of the ground. The oil is cleaned of natural gas or water, which is combined with it. Next, the petroleum starts on its way through a great network of pipelines. There are powerful pumping stations every 40 or 50 miles to keep it moving along the lines. The lines of pipe, alive with racing oil, run through forests and over plains to these silver discs. They're storage tanks where the oil rests briefly before it rides the waves in giant tankers. And they're masterpieces of shipbuilding, those tankers of steel. The largest navigate the sea at 15 knots and carry 5.5 million gallons of oil. The voyage of oil to the refineries. The refinery with its modern structures, technological towers, minarets of science, docks, office buildings, pageant of industry. Day after day, there is an endless flow of oil as the tankers discharge their liquid cargo. Unloading oil is a vast operation of piping through huge hoses. Discharged pipes on the vessel and receiving lines on the dock are connected, and a cargo of 5 million gallons is discharged in less than 24 hours. No two cargoes of crude oil are alike, so each boatload must be stored in different tanks, and each batch must be processed individually with laboratory tests to indicate the precise treatment for each. That is embodied science. Those masses of strangely wrought steel, forests of stacks, glowering and hissing boilers.
Reserve components of the armed forces. Another service station dealer might be a member of your local civil defense organization, or one of those fire eaters on the volunteer fire department. Perhaps your dealer is an unpaid member of the Board of Education, or serves on the advisory committee for civic improvement. Foreigners touring our country have commented many times that service station dealers are the most American Americans they meet. They say the dealers are cheerful and efficient. They reflect the freedom of opportunity we cherish so highly. That's why we say your neighborhood service station dealer is truly a man who is qualified to wear two hats. Here are some sick oysters. Just what made them sick and just how they are to be cured are questions that stumped an entire oyster industry. The trouble started down in Louisiana on the Gulf of Mexico, where the Louisiana oyster fishermen claimed that oil production was killing off the local oyster population. The oil companies didn't agree, but they decided to look into the matter. So they started what developed into a $2 million oyster research program. Scientists went out to the bedding grounds where they collected buckets full of oysters and then brought them to a special oyster research center of Texas A&M College, one of the laboratories established for the oyster survey by the oil companies. In the research laboratory, every type of condition is created for the oyster patients. A blanket of crude oil is poured directly on the water. Water is jetted through oil for 6 months. Oil drilling mud was emptied into the water. Even dynamite charges were exploded near test oyster beds. Every possibility was explored. After years of study and progress, the results were in. The test oysters showed no ill effects from oil, even under conditions which far exceeded those ever present during oil production. As a matter of fact, the test oysters were so happy, they brought forth new generations to share their lot. They never had it so good. Well then, if this wasn't killing the oysters, what was? It took time and money to find out, and the science...
The bottom. Providing adequate water facilities on a tropical plantation is a necessary and costly requisite in producing high-quality coffee. Now encased only in its final hull, or parchment, the coffee beans are spread out to dry in the sun. This takes from 8 to 10 days. Men must rake and turn the beans so that they all will dry evenly. Then, packed in bags, the dried green coffee is ready to be sent into the city. Here it is unloaded at a warehouse, where it will be inspected, sorted, and graded for quality. This initial grading is one of the most important operations in the selection of coffee. Today, mechanical methods are so perfected that coffee is sorted by machines with great precision.
Mixing plant, where they were combined scientifically and under rigid inspection into a finished product. With a maximum capacity of 24 cubic yards of concrete every 3½ minutes, the high-level mixing plant at Boulder Dam represented the ultimate in plant installations of its kind. Here, automatic equipment not only controlled the apportionment of the concrete ingredients, but in addition maintained a graphic record of every plant operation. From his post on the control deck of the mixing plant, an operator was able to direct the entire mixing cycle, from the initial weighing of the ingredients on through the complete mixing process. The human element was almost completely eliminated, as the mechanical equipment was capable of automatically selecting, measuring, weighing, and recording the proper materials in the precise amounts required for the production of a given mix, to which the recording dials had previously been adjusted and set. Here also we find the production line conveyor belt speeding up the process by carrying the component parts from the measuring and weighing hoppers into the batching bins, from which the materials were dumped into the 4 cubic yard capacity rotary mixers. Water was added in controlled amounts, and the entire mass thoroughly agitated as the last step in the economical and efficient manufacture of a concrete strong enough to withstand the enormous pressure to which the dam would be subjected. From the mixing plant, concrete was dispatched to all sections of the works, and because of the widely varying conditions prevailing, various types of containers and methods of transportation were involved. Motor trucks and electric trains were utilized as carriers, and containers varied from the 8 cubic yard capacity bottom dump buckets to the 4 cubic yard capacity transit mixers. The latter were used on long hauls, where it was necessary to agitate the concrete in transportation to prevent segregation of the mix. However, the major portion of the concrete handled on the project was carried in the 8 cubic yard buckets and transported from the mixing plants by electric train. A system of 9 aerial cableways spanning the canyon from rim to rim and anchored at either end to movable towers was utilized to carry the concrete and other materials from the points of train or truck delivery to the dam and other structures on the project. It was on June 6, 1933, that the first bucket of concrete was placed in the very lowest of the dam forms, 135 feet below the level where a few months previously had flowed the unchallenged Colorado River. What was to become the highest dam in the world began to rise from the impregnable rock of its foundation. as bucket after bucket of concrete was dumped into the forms.
Weighing several tons are placed in a soaking pit or open furnace and reheated to uniform temperature. When the ingots are white hot, they are taken out of the soaking pits and transferred to the blooming mills. In the blooming mills, the ingots are shaped and pressed by powerful rolls. The massive rolls exert terrific pressure on the hot steel, kneading it and flattening it until at last it can be worked into almost any desired shape and thickness. Steel is strong, hard, enduring. But the strenuous use to which steel is put today demands many special characteristics. More different kinds of steel are needed to meet the high manufacturing and engineering standards of the automobile makers than for any other purpose. And so, the modern automobile makers have laboratories for testing and improving the qualities of steel. In the laboratory furnace, we see how steel can be given special characteristics by mixing with it small amounts of other metals. Steel can be made extremely hard by adding a small amount of chromium. The chromium is added to the melted steel. After careful blending, the mixture is poured into a mold and then scientifically brought to normal room temperature. The hardness of steel to which chromium has been added is measured by denting it. A small, extremely hard ball is forced down into the steel test specimen.
The ovens. In Gary, Indiana, the quenching towers drench the carloads of coke hour after hour as construction forges ahead. Coke joins with limestone and iron ore in towering blast furnaces. Regularly, the molten metal flows into giant ladles. But just as regularly at Chicago, Illinois, work progresses on the new modern blast furnaces. There are 2 new ones there. They're just part of the $775 million construction and modernization program begun since VJ Day. That's a lot of money in anybody's language. Where does it come from? 228,000 stockholders of United States Steel have invested with faith in the future of America. They make possible through their savings the plants and equipment. And with management and employees, they make up the productive team that serves you, the public. They are your next-door neighbor, your grocer, your doctor, your local hospital, the company behind your insurance policy, the college where you send your son or daughter. They are all walks of life and all America. They each hold an average of about 50 shares. To them and to all America, the challenge of peace held no promise of easy victory. Up and down and across the land, as the men came home to the challenge of peace, new mills were being built right beside those in operation. In Vandergrift, Pennsylvania, for example, you find new facilities for the increased production of silicon steel, specially alloyed and processed steel to increase efficiency of electric motors and transformers. In the Irvin Works near Pittsburgh, you find construction of new facilities side by side with production of sheet steel for your automobiles, refrigerators, washing machines, stoves, and the cans on your grocer's shelves. America demands billions of them a year. Tin cans are actually steel cans, 98% steel and 2% tin. In Gary, Indiana, there is further increase in steel sheet and tin plate capacity. Production rolls along while the crews install the new machinery. As sections of the new mill are finished, they're immediately put into and increased production. Birmingham, Alabama is known as the Magic City. The wonder there in the Fairfield Works is the same you find north, south, east, and west. You find again the story of production and construction side by side. You find them converting a hot rolling mill to a cold reduction mill, improving the quality of steel for new and better pieces.